Okay, our last topic with the normal distribution is what's called the empirical rule. Okay, and so what the empirical rule does is it gives us kind of a guideline for the percentages of values that fall between certain standard deviations. Okay, so if you think about the example we were looking at in the last video, where we had um, salaries with a mean of 50,000 and standard deviation 10,000. A lot of times the way that we like to think about data, remember from the last lectures, were in terms of how many standard deviations they are from the mean, right? So for example, if you were looking at salaries less than one standard deviation from the mean, remember when we talked about that language, that means 50,000 minus one standard deviation, so from 40,000 to 60,000. Okay? So 50,000 minus 10,000, 50,000 plus 10,000. So salaries less than one standard deviation from the mean would be in this range. If you think about this in terms of z-scores, if you actually go through and calculate the z-scores, well, since this is one standard deviation less than the mean, 40,000 minus 50,000 divided by 10,000 is going to give you a z-score of -1. 60,000 minus 50,000 divided by 10,000 is going to give you a z-score of +1. Okay? And so if you look at the percentage that are less than one standard deviation from the mean, that are in this range, the percentage of salaries that are between 40,000 and 60,000, well, since it's going from a z-score of -1 to a z-score of +1, if you look at the corresponding percentiles, right, we know from our table, looking at our table, if you look at -1, 15.87% are less than z equals -1, and for z equals +1, 84.13% are less than z equals +1. Okay? And so the percentage between, in this example, 40,000 and 60,000, but in general, between anything one standard deviation below the mean and one standard deviation above the mean, is going to be 84.13 minus 15.87, which comes out to 68.26%. Okay? And so nothing about this depends on the particular problem that we're looking at. Okay? So in this particular problem, this tells us that 68% of the salaries are going to be between 40,000 and 60,000. But in general, what this tells us is that 68.26% of the salaries are going to be between one standard deviation below the mean and one standard deviation above the mean. Okay? And that calculation doesn't necessarily depend on, it depends on what the mean and the standard deviation are to find the values, but the percentage is always going to be the same. Okay? So this is called the empirical rule. And so what the empirical rule says is that roughly 68% of values are between the mean minus the standard deviation and the mean plus the standard deviation. So 1 standard deviation from the mean. If you take mean minus standard deviation, mean plus standard deviation in that range, 68% of your data values should be in that range. You can do the same thing for 2 standard deviations away from the mean. So if you do that, if you took the mean minus 2 times the standard deviation and the mean plus 2 times the standard deviation. So in the case of our example, we would go from 50,000 minus 2 times 10,000, so 30,000, to 50,000 plus 2 times 10,000. So from 30,000 to 70,000, in that range, 95%. Again, roughly 95% of the values are between 2 standard deviations of the mean. Okay, and that comes from the exact same reasoning as the way we found 68%. If you take the values for a z-score of -2 and a z-score of +2, you're going to get 97.73 minus 2.28, and that comes out to right around 95%. Okay? And then finally, the last part of the empirical rule says that 99.8% of values are between, 99.7. 99.7% of values are between 3 standard deviations. Okay, so, and again, that comes from, if you look at the z-scores for 3 and -3, which aren't on our sheet actually, you can find that it's 99.7% of the values are between mean minus 3 standard deviations. Okay, so in the case of our problem, 68% of values are between 40,000 and 60,000, right? So in our example, we had mean 50,000, standard deviation 10,000, and so 68% are between 40,000 and 60,000. 95% are between 50,000 minus 2 times 10,000, so 30,000 to 50,000 plus 2 times 10,000, 70,000. And then 99.7% are within 3 standard deviations. So 50,000 minus 30,000, 20,000, and 50,000 plus 30,000, 80,000. Okay? So if your salaries are normally distributed, 68% will be in this range, 95% will be in this range, and 99.7% will be in that range. And so that gives us kind of a quick way to look at data. And again, we can use this to see if our data is roughly normally distributed. If it fits these, we find the mean, we find the standard deviation, then we find that, 65% are in this range, 93% are in this range, 100% are in this range, something like that, something very close, then that again gives us more evidence that it's normally distributed. We can also use it to kind of make very quick judgments and say, oh, okay, well, 95% of the values are going to be in this range. And that can be very useful. Okay? So that's called the empirical rule. And it fits any data as long as it's normally distributed, no matter what the mean and the standard deviation are.